Okay. So I think I got this down. But there's your M23, right? Yeah. I think I had the camera on, but just to give you a quick synopsis and then look at the standard basis. Typical element of M23, 2 rows, 3 columns. Here's another element, M23. If I add these two, do I get a matrix in M23? Well, pretty clearly I'm going. Additive identity is this, because if you add this to this, you get this. Additive inverse, you just take the negatives of all the entries in this one and you get its additive inverse. So when you add this to this, you get the identity. That's what an additive inverse is. You got to get used to that. You got to get used to proving that. Okay? For at least simple cases right now. Standard basis for M23, what we said, what I said was, simplest matrix you can write in M23 that isn't 0. Okay, well, I think somebody wanted to use an identity. Well, you know, M23 doesn't have an identity because it's not square. But that's on the right track because it's got a lot of zeros. The more zeros you have, the simpler the matrix generally is. Okay? Well, you got 6 entries. If 5 of them are 0, that makes the result pretty simple. And the simplest non-zero number you can put in is probably 1 because it's really easy to multiply things by 1. Okay? So these 6 matrices cover that. Okay, is that a basis? Is it linearly independent? Well, C1V1 plus C2V2 plus C3V3 plus C4V4 plus C5V5, not giving myself enough room, plus C6V6 equals the 0 matrix, which is this, right? Or the identity. Okay? Does this imply that C1 equals C2 equals so forth? I'm going to write them all out. That they're all 0? Well, if you just look at it, I mean, C1 times this is going to have a C1 here, then you're going to have a C2 here, C3 here. Add them all together, you got C1, C2, C3, C4, C5, C6. And if that's equal to the 0 vector, then every one of them has to be 0. Now you want to write that out. You want to write it out for yourself. You know, it's okay to sit there and watch me do it and point. Take what I've done, but then get to where you can write it out yourself and know what needs to be written out, right? Okay? It's not hard. Once you get over the hump, it's pretty simple. And your book has examples. I mean, read the thing, you know. Okay? Span. Writing it fast because we don't want to spend a lot of time on this. Okay? Because it's actually quite simple. Okay? If you write this out, where V1 through V6, of course, these 6 matrices, you're going to find that C1 equals A11, C2 equals A12, and so forth. But you need to write it out to see that. Because if you don't write it out, you're not used to writing it out, and then get the test and you need to write it out and you don't know what to do. Because you're under pressure of the test. Even though you do know what to do outside of the test, you won't inside the test. You got to practice, you got to write them out. Okay? So, you'll be able to verify this showing that that is a basis. Okay? And then you can verify whether something else is a basis by writing out the same equations. Now, if you write this out in general for different V1s where you don't have a lot of zeros and stuff, you're going to get a system of 6 simultaneous equations and 6 unknowns, right? Meaning you're going to get an augmented matrix that's 6 by 6 over here. And then the augmentation, either with the zeros or with whatever. Your A11, A12, and so forth would be here. Okay? Write it out, think about it. It should convince you that this is as much a vector space as R3 or R2. Okay?